Hi everyone, welcome to this session on streams in Java 8. In this video, we'll explore what streams are, how they work, and the powerful operations they enable. We'll begin by understanding the concept of streams, learn how to create them, examine their sources, and finally dive into the operations that can be performed on them. So without further ado, let's jump right in. What are streams? Think of streams as a sequence of data. They allow you to process collections of data in a functional and streamed way. Imagine streams as a pipeline, much like an assembly line in a factory. Consider a scenario where a bike is being manufactured. First, you will need the spare parts to be arrived. Second in the sequence would be the parts are transformed and assembled step by step. These are intermediate operations. And third, finally, the completed bike is tested and delivered. This is going to be your terminal operation. Your spare parts being your source, your parts being transformed and assembled being your intermediate operation, and your completed bike is going to be your terminal operation. The sequence of these operations matters. If the steps are skipped or reordered, the process will fail. Streams work similarly. They take data from a source, process it through a series of intermediate operations, and then produce a final result using the terminal operation. Why streams in Java? In Java, we've long used the collections framework to access and manipulate data. However, collections have limitations, especially when it comes to transformation and parallel processing. This is where streams come in. Streams provide advanced capabilities to transform data, filter it, and process it efficiently, even in parallel. A stream pipeline consists of three key parts: a source, intermediate operation, and terminal operation. Your source is going to be the origin of data, like as in list, array, or another stream. Your intermediate operation is the transformation that is going to be applied on the source that we have received, which is going to be filtering or mapping. Finally, we have our terminal operation, the final step that produces the result. Example, collecting the data into a list or printing it. Streams are defined in java.util. So we know what is stream. We know that stream is a pipeline. So in order to create stream, you will have to define your source of your stream. So you will be able to create an empty stream calling empty method. You'll be able to create a single element of stream. You'll be able to create a multiple elements. You will be able to create finite number of elements, and you will also be able to create infinite number of elements. Stream operations. Streams support a wide range of operations categorized into intermediate and terminal operations. Your intermediate operations are not executed immediately. They are evaluated only when a terminal operation is invoked. Example, filter, map, sorted, distinct, limit, and skip are the operations that are performed only when a terminal operation is invoked. Your filter will retain the elements based on a condition. Your map will transform your elements using a function. Your sorted will sort the elements in a natural or custom order. Your distinct will remove the duplicate elements. Your limit and skip will restrict the number of elements or skip some. Your terminal operations trigger the execution of pipeline and produces a result. Examples include collect, for each, reduce, and count. Your collect will gather elements into a collection like a list, set, or map. Your for each will perform an action for each element. Your reduce will aggregate elements into a single value, and count will count the number of elements in the stream. Some of the key characteristics of your streams are lazy. Intermediate operations like filter and map are only evaluated when a terminal operation is called. Second, streams don't modify the original source. Streams work on copies of data, leaving the original collections unchanged. Third, parallel processing. They can process your data in parallel, improving performance for large data sets. To solidify your understanding, let's practice some stream operations like filtering, mapping, collecting with different data types and scenario. Let's now move on to the demonstration to see the streams in action.